Welcome, good morning, and good afternoon to you, Eaton Nation. I'm Josh Kingsley, your host of All Things Control by Eaton. I want to welcome everybody to our second Ask the Expert session for PLCs. In today's session, we will be covering some of the questions we weren't able to get to in session one, and we're also opening the floor to you, the viewer, to get questions answered and some of the other things about PLCs you might be curious about. But first, let's welcome back our guests. Say hello first to our product manager for control and automation. Please welcome Adam Bainbridge. And also back today, your friendly neighborhood application engineer. Please welcome back Travis Quinn.
Hey guys.
Welcome, gentlemen. All right, and as a note to you all the viewers, you can ask your questions via the comment sections below on LinkedIn or Facebook. And of course, we do have to make mention of our sponsors. This session has been brought to you by the Easy E4 Nano PLC. Visit eaton.com/easye4 to learn more about the product. And if you want to learn more about PLCs, please visit eaton.com/automation content to explore our content. All right, guys, let's get to work. Our first question is going to come from the pool that we had from our previous session. This one is from Jessica. And this is actually a pretty popular question in the poll as well. What do I need to create a PID control loop in my process? Travis, can you help us out?
Absolutely. Thanks for the great question, Jessica. So first thing you're going to need, obviously, is a sensor for feedback, a PLC, wire or cable, and then obviously also a power supply. Another key thing to note is that the PLC that you have must be capable of executing a PID control block. And Drew, if you could please pull up the diagram. Since Jessica, you did ask this before, we did put together a little diagram for you to help this make a little more sense. So this diagram is actually the control loop used to control the temperature of a room using damper control. So as you can see, the RTD, or the resistance temperature detector, feeds back into the PLC along with the given set point, which are then compared and put through a PID block in order to actually implement an output signal, which is used to then control the position of the damper. That damper that will then fluctuate in position to allow more or less hot air into the room. Again, this is a great setup that is commonly used, and thank you for the question, Jessica.
And of course, for more information about this and to learn more about how to set up the software, please visit eaton.com/automation compass. All right, our next question is going to come from Gloria. How are PLCs used in correlation with safety applications? Adam, will have you take that one. Adam, we can't hear you. All right, so we're gonna jump back to you, Travis. We'll get into one more question for you. This one's coming from Miguel. How can I control a variable frequency drive with a PLC?
Sure, great question, Miguel. So there are actually a couple different ways that you can control the speed or control a VFD in general, or variable frequency drive using a PLC. So the first method that's commonly used is hardwire control, and the second method would be field bus communications. So if you just need an enable signal and maybe a separate signal to control the actual speed of the drive, I'd probably use hardwire control. However, if more signals are needed, I would definitely go with a field bus control such as Modbus TCP or Ethernet IP. Traditionally, however, nano PLCs, which we are commonly referring to within this episode, do not actually have field bus control, at least not as a master. However, the Easy E4 will be launching Modbus TCP Master Control in 2021. Back to you, Josh.
Nice. Sounds like a great feature. I know it's starting to get a little cold in your neck of the woods, Travis. Are we scraping the sidewalk already, or do we have something else going on?
Getting there. Definitely getting there. Hoping that summer comes back here within the next couple weeks.
All right, perfect. I wouldn't hold your breath on that. Adam, do we have sound back?
Yes, I believe so.
All right, can we help Gloria out with our question about PLCs used in correlation with safety applications?
Yeah, great. Sorry about the technical difficulties. I don't know what's happening here. I see my videos twitching as well. But to answer your question, Gloria, that is a good one. A very difficult one, but very important. So safety is a huge concern, and there's a bunch of different ways to solve it. The first thing I'll point out as far as PLCs go, there are safety rated PLCs on the market, and those are used to monitor safety conditions and control safe outputs. But you don't always need a safety rated PLC for applications with safety requirements. In many applications, safety relay is a great choice to use in conjunction with the PLC and whatever motor control you may be using. A good example would be a conveyor. If you need an emergency stop on that conveyor motor, and that's the only safety requirement you have, then using an emergency stop safety relay with whatever SIL rating your application requires is probably the most cost effective solution. Now, where the PLC comes into play, if you have a lot of safety requirements, a lot of safety inputs, a lot of safety outputs, the PLC can really save you time and effort when configuring those applications. But most of the time, you only have one or two safety requirements, and I think the relay is a great choice.
Okay, perfect. So just to expand a little bit, it sounds like the most important thing if you're working with a safety application or requirement, it's just really important to do all the research and the quantifying up front, correct?
Yeah, there's two ways to go about this. Sometimes your end user will have a specification, whether it be SIL 1, SIL 2, or a performance level, such as performance level E. Those are done with letters. So typically, ask the end user if there's a specification, or there's safety surveys that can be conducted to help determine what those requirements are. And once you have those requirements in hand, you can choose the right products, the right combination of products that meet those levels.
Cool. So get your risk parameters in order. All right. Thank you, Adam. And for anybody just joining us right now, this is session 2 of Ask the Expert by Eaton for PLCs. And don't forget, for more information, please visit eaton.com/easyE4 and eaton.com/automation compass. All right. Looks like our next question is going to be back to Adam again, and this one's coming from Sarah. Why is data logging feature so commonly used with a nano PLC?
Good question, Sarah. This one comes up a lot more and more these days. That the traceability in applications is really becoming an important requirement, and each industry has different requirements and different needs for different data logging features, and there's different ways to accomplish it. If you're in a process industry such as wastewater treatment, there may be legal requirements that you have to track how much pollutants, what the levels of chemicals are at any given moment in time, and that's really important as a legal requirement. In other situations, such as manufacturing, just knowing how many parts are produced, how many defects were made is really important. The good news is it's getting easier to do. As far as nano PLCs are concerned, it's becoming more common to have SD cards built right in. Our EZ4 uses a micro SD card, which you can get very inexpensively in very large sizes. So they'll hold a lot of data, and you can capture that data right in the EZ4. You can timestamp the data, you can track it. There's really a lot of power there. Additionally, once you have the Ethernet port on board, you can extract that data using a higher level SCADA system, which gives you a lot of capacity to share that data with other systems within your facility as well.
Perfect. All right. So threw out a lot of acronyms in there. I just want to pick on one here in particular. What's a SCADA system?
It's a supervisory control and data acquisition, and a SCADA system is typically used in conjunction with PLCs in large process environments. So it doesn't do the real-time control that a PLC does and control the inputs and outputs. However, it might start and stop the process, but most importantly, it handles alarming and monitoring all the data that multiple PLCs and different processes might have within that facility. It really just pulls it all in so you can get a view of that plant or that process all on one screen in an instant.
Perfect. All right, so the next question, I think this is probably going to be a good Adam question as well. This one's coming from Arturo. Are you planning to make any major Xsoft Code Assist software updates soon?
Yeah, that's a great question. I think obviously a big trend is IoT, Internet of Things, and making a lot more things easier to use using those new tools that we have available. So I think across the board, this isn't just Xsoft Code Assist, but that one is absolutely included. Being able to back up your projects, being able to more easily interact with products, using the cloud, using new use cases. So really across the board, really looking at how we can make our products easier to use with new technologies that are available.
All right, so software is a focus, is what I'm hearing out of that.
Absolutely is.
Good stuff. All right, Travis, I've got one for you. This one's coming from Jesus. What's the best, most cost effective way to start thinking about and learning how to program Eaton's PLCs?
Sure, great question, Jesus. Also, apologize if you do hear any jingling in the background. My dog Lambo actually just broke into the room, so bear with me here. But again, the best way to most effectively look at which type of PLC system that you want to use is start by actually looking at what the requirements of your system are. So if you only need, let's say, less than 100 I/O points, you're probably going to want to look at a nano PLC system with some expansion I/O. However, even if you need a little bit more than that, and maybe your throughput on calculations are slightly more than the nano PLC allows for, I would start looking at maybe the micro level or a small level PLC. So really what you need to do is break down, how many I/O points you need, what features you need, and as well as the horsepower, so to say, that you need in your PLC.
Okay, good stuff. Thank you very much, Travis. And we hope we get to meet Lambo here before this is all said and done.
Absolutely.
All right. Next question that we have, what kind of sensors work with PLCs? And I think, Travis, this is going to be a good question for you as well. This one's coming from Simon.
Yep, another good question, Simon. So kind of like the last question, some of those I/O points obviously can be sensors. So sensors that do work with PLCs would be anything from analog sensors to digital sensors to also sensors that communicate using field bus controls such as Ethernet IP or maybe IO Link. Eaton in particular does have a solid line of photoelectric and proximity sensors, as well as limit switches. So photoelectric sensors are commonly used, for instance, with a counter to count parts going through a process where you probably don't want to have physical contact with the sensor. So a lot of common places where you'll find these types of sensors are definitely in food and beverage industries. Otherwise, the prox switches that I was referring to, or proximity switches, are used to indicate the presence of a metallic object, such as maybe like a metal arm moving into a desired location on a machine. And then lastly, the limit switches that I was referring to previously are used to indicate the presence of any physical object in a specific location. However, it does require contact with the object because those limit switches themselves do have physical arms that need to rotate to trigger the sensor to be on or off. So an example where you might want to use those switches would be maybe on a packaging machine to count boxes moving down a line.
Okay, perfect. Well, it sounds like there's plenty of applications you can get into using PLCs and sensors, and it's almost like they communicate together well.
Absolutely.
Good stuff. All right, so the next question's coming in from Juan, and this is a two-part question. How redundant is the PLC, and what about the PLC using HART, which I'm assuming is the Highway Addressable Remote Transducer protocol? Adam, I'll let you do that one.
Yeah, to answer the first question, I mean, when we're talking specifically about our nano PLCs, and this is really across the industry. There really isn't a way to set those up in a redundant application. Typically, you need to go up to micro or small to have those redundant capabilities, and it's really a lot to do with software. You need to have the IOs split, wired to two exact clones of the actual hardware. And then the software kind of keeps them in sync and it knows which processor is in control. And then if something fails, it switches over to the second PLC. So, there are different levels of redundant PLCs. We had a question about Codesys earlier. Codesys absolutely supports redundant PLCs, and you can use those in Eaton's micro and above programmable logic controllers. So it absolutely is possible, and it's fairly easy to set up. The physical installation is honestly the trickiest piece of solving that. The second about HART. Yep, HART is a communication protocol, as Josh alluded to. What was the specific question there? How does it relate to PLCs?
Yeah, no. So the question is, HART with a PLC, and I think it's just an ask for an overview about using HART with a PLC.
Yeah, it's pretty uncommon. I will say Eaton's PLCs do not include HART protocol communication standard, but you can get gateways to translate that to like Ethernet IP, Modbus TCP, and that is typically how we see them integrated. So I think that answers your question. Typically, you'll need some kind of gateway to translate it into something the PLC speaks. I'm sure there are PLCs out there that have HART cards built in, but it's really not very common.
Okay, perfect. All right, so Travis, got another question that I can ask you. What kind of upfront checklist would you have that you would recommend using if you're going to build an infrastructure that's going to have a PLC? What are the things that you want to make sure you're considering?
Can you repeat that one more time, please? I lost you a little bit there.
So if you're putting together an automation process with a machine, what's the checklist that you would start with if you were going to integrate a PLC? If you're building a system from scratch, what is the approach that you would take to build the architecture fundamentally correct?
Sure. Yep, another great question. The first thing I would definitely look at is the type of sensors, the type of speed of the application, and then also, I guess the throughput. How fast do you actually need that data calculated? All those things definitely go into what PLCs and what equipment that you need. So, for instance, if you have maybe a conveyor application, right, where you have a box that you just need to control the speed of, very simple. All the boxes going down the line need to just go at maybe 15 miles an hour, and you just need to start and stop it. I probably then look at a nano PLC. However, if you have maybe a packaging machine or like a boxer, which needs maybe a little bit of motion control, and it needs to be able to calculate some of those function blocks inside the PLC a little bit quicker, you're going to need to bump up to like a micro level. And then, of course, you need to look at how many I/O points you need as well with your sensors. So it really does boil down to I/O points, the speed of your application, as well as throughput of calculations.
Yeah, I often see, to chime in here,
Okay, thank you.
I often see people getting very comfortable with a certain class of PLC. Usually it's a micro because they're very powerful, they're very flexible, and they apply those kind of across the board for the most part. But oftentimes a nano PLC can solve those requirements. So I urge you, as technology certainly improves, to kind of just look at what the requirements truly are and open it up, because you could save a significant amount of money because there are huge price differences as you change classes of PLCs.
Great point, Adam.
So, Adam, quick follow up to that. We're throwing out all these different classifications of PLCs. We've heard of micro and nano. How many classifications are there?
Yeah, I think Travis mentioned them earlier. There's nano, micro, small, and large. To be honest, that doesn't mean a whole lot to a lot of people. Really, the difference is I/O counts for the most part, but even that line is getting pretty blurry. And really, the hardest difference is just how they program. Whether it's registered base or not, or tag based. So the programming type, especially specifically around the memory addressing, really defines that. So definitely large is for like automating an entire production line, such as automotive manufacturing, and there'll be a huge rack with thousands of I/O. That one's pretty clear. Nano and micro is a little bit blurry, and kind of the same with small. So I'm sorry I don't have a better answer for you, because there is a lot of overlap, and it really just depends on what you're trying to do.
Yeah, so personal preference, application, and then having a good support system behind you. I mean, to me, that did kind of answer the question, and it's just really important to, make sure you put all your thought up front when you're building and architecting a system.
Yep.
So quick reminder for those of us just joining us. This is session 2 of Ask the Expert for PLCs, and don't forget, for more information, please visit eaton.com/easy4 and eaton.com/automation compass. So we got our next question, and this is going to be about software programming. So I think I'll give both you guys a chance to give your thoughts on this. This one comes from Allie. They've started learning ladder logic, but they're trying to take their PLC programming to the next level.
I'll take that one. Ladder logic is a great way to learn, because it has a very sequential flow. It executes the first rung on the ladder, then the second, then the third, then the fourth. And it's really easy to see that in your mind and understand how the program's going to execute. And you can understand how certain checks are happening, because it reads like a book. It starts at the top left, goes right to left, top to bottom. So we are all very much programmed in our heads to think that way. So when looking at a ladder chart, we can see very easily, this is the steps the PLC is going to take. That has a lot of advantages, because it's easier for us to quickly understand how that program works. When you want to take it to the next level, different programming languages really open up, and as we have kind of, modern computing has multi-threaded things where it's kind of thinking about a couple different things at once. You can kind of break that sequential flow a lot easier and really control multiple different things at the same time. So different languages are better at doing that. I like ladder because, like I said, it flows very easily. But I'll tell you, for doing math operations and really computing a lot of numbers, structured text is the best. So I kind of look at it, what am I doing? If I'm just looking at binary inputs and checking them all in a certain sequence, I'll typically use ladder. It's what I'm comfortable with. But if I see there's a lot of math, floating point math to manipulate, I jump right to structured text. The good news is, a lot of modern PLCs you can mix and match, including the Easy E4. You can write blocks of code in structured text and then write it in ladder, kind of mix and match, so you can kind of get the best of both worlds in a lot of cases.
Yep. And then I'll just add onto that a little bit. So once you also start getting a little bit more involved, if you are starting with ladder, I'd say the next step, which is definitely useful more in ladder than it is in structured text, is for the Easy E4 in EasySoft itself, there is the oscilloscope feature, which allows you to actually go online and view the data. You can actually manipulate operations using simulators, and it's a lot more easy to see and visualize than within structured text. However, another thing to note is, as you are trying to really maximize and get as much out of your PLC as you can, ladder logic is actually faster than maybe function block diagrams, and structured text is faster than ladder. So there are little nuances that you can actually do to really try to get the most out of your PLC that you can. So that's kind of where I see things going when you're trying to go to the next level.
Perfect. So a quick follow-up question for Adam. You did mention that you can interchange the different, these are programming languages, right?
Yep.
So you can interchange the different programming languages. Do you have to have something that marries all of them together? Like, does the EasySoft do that, or is there another method that you can use to make everything work? Because this is a little bit beyond my personal scope. So this is sounding pretty complicated. If you could just dig into that a little more.
It is. The Easy has absolutely the easiest way to do it, but it limits you in some ways. So this is, again, some of those differences between the layers of PLCs. So the Easy, you have a main program, right? And you can call another program. In the Easy, it's called a function block. You can call another function block within that program. So when you're in your main program and you create a math block that's just doing a simple conversion, let's say it's adding adding two numbers together and dividing them both by 2 to get an average or something like that. So you would place that block in the main program, and then elsewhere you can edit that code for that block in a different language. So the main program is the one executing. When it gets to that rung, it will move to that block and then execute its code. That's the simplest way, right? When you move on to more advanced programs like Code Assist, there's a whole task manager. It's really complicated. It's super powerful, but you can create different tasks that run off of all kinds of different triggers. You can have them triggering. You can have one program triggering every millisecond, another every 5, another every 50, or you can have event-based triggers where if an input changes state, then it triggers that program to run, and you really get a lot more power. But it gets difficult to manage. You have to be careful, because if you put everything in like a 0.01 millisecond task and you have 5,000 lines of code in 4 programs, it's never going to finish executing. The processor typically won't let it execute that, and you start to get variations on what you expect. So you really have to put a lot of thought when you have that flexibility to make sure that you're not overrunning the processor and starting to get unexpected or untimely outcomes.
Okay, perfect. So looks like we got another question coming in. This one's from Eric. Can you describe a bit about the API functionality?
Okay.
Sure.
You got this, Travis?
You can go ahead. I'll chime in after you on that, Adam.
Okay. So yeah, an API is a standardized programming interface, right? So this is used a lot in the IoT world. In fact, if you have an Amazon Alexa at home or some of those tools, they all use APIs. What they do is it creates a standard way of interfacing two different things together. So if you have a smart light bulb and a smart speaker, there's an API that's written to kind of link the two together. It's kind of a standardized language. So when we move on to the easy, it's the same thing. We have the standard programming interface that can be linked up to all of these other smart IoT things, and it standardizes your program and the tags within that program to talk to those other devices. So it really opens up beyond common industrial protocols what you can communicate and how you can link devices together.
Yep. So I guess just to add a little more clarity. So our APIs are Java APIs, and what really they do is they are objects of code, as Adam was describing, that basically just help you get inputs, outputs, and set the two via an HTML file or something similar to that. So really, you can manipulate and gather data in programs such as Excel. Otherwise, you can also link it maybe to a custom web page or server. So they are definitely handy tools and something very useful once you get to learn the Easy E4 itself.
All right, perfect. All right, guys, we are kind of getting to that time, so we do need to get one more word from our sponsor, but I do invite everybody to please stick with me for the final roundup immediately after. All right, what a great versatile product. And don't forget, for more information, please visit eaton.com/easy4. And if you need help with your PLC applications, please visit eaton.com/automation compass. All right, well, a big thank you again to all of our guests who joined us in this second session, and also a big thanks to Adam and Travis.
Thanks for having me.
Yeah, always a pleasure, gentlemen. And again, thank you to the audience for being here with us today. I'm Josh with All Things Control by Eaton, and until we meet again, don't forget to keep it in control. All right, hey, hold up.